ahead and get started. Good afternoon, everybody. My name is Ben Jewell. I'm an extension educator based in Otoe County, Nebraska, and here with our Nebraska Extension Regional Food Systems Initiative. I'm excited today to wrap up our 2025 speaker series, Food System Speaker Series, and we're going to jump right into it today. So I'm going to turn it over to Saleh, who's going to talk to us about small-scale irrigation work here at Biosystems Engineering at UNL. Thanks for joining us. Appreciate it.
Yeah, thank you, Ben, and hi to everyone joining or watching this later. Let me share my screen here with you. Okay, should be coming here any minute. Okay, let me know if the share screen is not working. Okay, great. Thanks again. This talk is going to cover a little bit about the small scale irrigation project that we've been working on at UNL for probably about 3 years now. As Ben said, I'm Saleh Taghvaeian. I'm an irrigation engineer in the Biological Systems Engineering Department. I'm based on East Campus, and my area of research and teaching is irrigation engineering, primarily on larger scale systems, but in the past couple of years, 3 years, on this small scale irrigation. This is a little outline of what I'm going to be covering today, but starting with why this work on a smaller scale irrigation and why it is important. Let me show you this map, which is the counties in Nebraska, the ones that are in darker shade of green. These are the counties that meet the USDA definition of food desert, and you can see that definition there. So it may be a little bit difficult to believe this, but in Nebraska, we have many counties that are designated food deserts. They have limited access to food. And then if you look at the average rate of food insecurity, Nebraska, based on the latest estimate, is at 12.2%, which is just a little bit above the national average of 11.2%. So it's somewhat of an issue, a challenge to address here in a state. When you combine this with the fact that some of the rural grocery stores have been closing down, you can see why the combination could cause issues for some residents of these food desert areas to have access to healthy, nutritious food and produce. So that was one of the main reasons for starting this. Also, another thing is we've been seeing some growth in a smaller scale and a specialty crop production across the state, which is a positive thing. But with that, it means that we need to provide more research and more extension and more support for those who work in this area. And you have to consider that these smaller scale systems are highly dependent on irrigation, especially if it's a production under protection in greenhouses and high tunnels. Then you're practically in a desert. You don't get any rainfall, so you have to have irrigation. It becomes more important to have it. You could be on the eastern edge of the state and in the very humid, wet year like this year when it started raining in June or July and never stopped, but it's still under plastic. You're getting zero rainfall. There are some gaps in technical guidance for small scale irrigation and especially irrigation under protection, mostly because what we have and state and federal agencies have are largely designed for larger scale row crop systems, center pivots and subsurface drip irrigation and gravity irrigation systems. So we don't have much for small scale. But also we have to understand that smaller scale systems have different hydraulics, different components, where you buy these components, the quality of the components, all of the characteristics of the hardware are different than larger scale, and the management is different than larger scale too. So it requires its own research and extension efforts. The goal of our program here on a small scale irrigation is to generate research-based guidance on the design, evaluation, and management of a small scale irrigation. to ensure that we achieve high water use efficiency, crop productivity, and decision-making capacity for all small-scale producers in Nebraska and hopefully in the region. One of the initial grants that funded this project and allowed us to start this program was from Nebraska NRCS, and we partnered with them. And the main reason was that as NRCS was getting these cost share programs and they were getting more requests from small scale producers, they were feeling the need to develop guidelines for small scale irrigation design, management, and evaluation. So we were talking about how we could work together at that time, and this came up as a top priority area. So we started this research evaluation and training program, and today I'm going to focus mostly on the research that we have been doing. The research has been done at UNL facilities. The evaluation of the systems has been done mostly on commercial farms, and I'm not going to cover that today. Then we've offered a few training events. And again, for the interest of time, I'm not going to cover the training either. So what we've done on the research side at UNL facilities is that we worked on a few high tunnels that are on the east campus of UNL. We had a few high tunnels that were not in good shape, so we worked on them a little bit, added plastic covering. If the pieces needed replacement, we did that, and we brought them into operating conditions. And then for the past 3 years, we've been growing crops in them. On the evaluation side, like I mentioned, it's been mostly on commercial farms. So we've conducted a few audits around the state and working with producers on helping them with the irrigation issues and questions that they're facing. The NRCS partnership, and I mentioned that when they need to develop these guidelines for small scale irrigation projects. So this is one example of the design and drawings that they developed, and we work with them on developing these drawings. So any small scale producer who goes to Nebraska NRCS and requests for cost share, equip funding, they'll have to meet some requirements defined by NRCS. So this was one of the steps that what would this drawing look like? What are the components of a smaller scale irrigation system? We probably don't need some of the components of a larger scale system. We may need some additional components. So this is an example of just how we work with NRCS, and we joined our efforts and expertise to come up with some guidelines and designs for small scale producers. Now, what we do on East Campus, this shows the high tunnels I told you about, and for the rest of this talk, I'm going to focus on this part of it. These are the 3 tunnels, and as you can see here, these tunnels are different in their width. The one to the left, which is on the east side, is 20 feet. So as the one to the right, the one in the middle is 16 feet wide. They also have different lengths. The one to the left is about 40 feet long. The other 2 are 96 feet long. They also have different shapes. So you see the 2 on the sides is hoop shaped, and the one in the middle, I think, is called the Gothic style of the frame. And then sidewalls are a little bit different. So the 2 on the left, we would rise up the sidewalls, and when it gets hot in the middle of the summer to get more airflow. The one on the right, to the west of the other 2, the sidewalls are fixed at the bottom to the boards, and we never lowered or raised the sidewalls. So it was always like that. It got hotter and more humid in there. We just wanted to kind of create some of the different combinations that you see out there, and then look at how we may want to go about managing irrigations in these different environments. We also tried different crops. We've had lettuce, both romaine and loose leaf lettuce in spring and fall seasons. What we've done in the past 2 years is start with a spring season of lettuce, take advantage of the high tunnels to start early and grow lettuce, and then go into a summer season of bell peppers, jalapeno peppers, or tomatoes. And then in fall, we go back to lettuce, fall season of lettuce, and again, take advantage of the high tunnels to extend that growing season just a little bit. So when it comes to irrigation, there are really two main questions that we have to answer. What irrigation system should we choose for a smaller scale? There's a lot more variability and diversity in the market. Larger scale row crop systems, at least in Nebraska, I think about 90% of our systems are center pivot. So it's then maybe you're thinking about the brand, but with small scale systems, that's one question. Even if you go with something like drip and you want drip tape, there's still a large variability in the market. And then the second question is, now that I have my system selected and installed, how do I go about managing irrigation? How much water do I apply? Questions like that. And we try to look into both of them. Part of the high tunnel is reserved for those training events and demonstrations. So we have different types of systems there, drip systems and micro sprinklers. But for our research, we went with drip tapes, and we went with Toro brand. And we're not endorsing any specific brand, but this was one that was available to us, and we could get it for 3 different discharge rates. So if you look at here, and let me see if I can get a laser pointer going. Okay. So it's a 5/8 of an inch diameter with emitter spacing at 8 inches, which is not too wide, not too short for us. But then we had these 3 different rates, which is very typical that when you go buy these systems, you can choose from different discharge rates. In this case, we had 0.25, 0.56, and 0.75 gallons per minute per 100 feet of this drip tape. So the only thing that was different was how much the emitters were discharging. So we could kind of create an ideal irrigation with the 0.56 one, but also an under-irrigated condition and an over-irrigated condition with the other two, and look at the impact of the irrigation management and find out which method really does best. This photo shows a little bit more about this specific product, Toro Aquatrax. You can see that how this is what it looks like when you purchase it, and this is kind of like showing you the inside the emitter, the design of it with the filters. Water enters this chamber and then goes through this zigzag path and then comes out of the cut on the tape through here. Now, the other important question is how to manage irrigation, how to decide how much water to apply. And this is the approach that we decided to follow. We decided that we want to estimate the water requirement of our crops and vegetables in the high tunnel, and then apply irrigation to meet that water requirement, or in another way to say it is to replace the amount of water that the crop has used. The way that we decided to do this was to estimate grass ET, and ET is evapotranspiration water use for grass from Nebraska mesonet, and then multiply that by canopy cover, what percentage of ground is covered by the crop canopy, and use that as an estimate of crop water use in these high tunnels. That's pretty much the easiest, the most simple method that you can find out there, that's still based on scientific principles and available data in Nebraska. So the idea is, if you find the nearest Nebraska mesonet station, you can get the water use ET, water requirement for a grass surface. Then you can say that if I have something like this that doesn't cover the entire ground like grass, I'm going to estimate that percentage coverage with an app that I told you about in a little bit, and then I assume that that is the amount of water that my crop needs. So in this case, the app we were using is telling us that the area of the ground covered by canopy is about 26%. So the water requirement for that day for this crop would be 26% of whatever the grass requirement is for the nearest Nebraska mesonet station. You can go to CropWatch, their GDD and ET information website to get the grass ET very easily. So this is top of the page. And if you scroll a little bit down and click on that GDD and ET tool, you get to this one. And then further down on the same page, you can pick the mesonet station that's nearest to the location of your site. Then you can pick the crop. In this case, we would pick grass, and then you give it an emergence date, month and day. And then if you do that, it gives you water use estimates for grass for the past 7 days, the past 3 days, and the next 3 days from the forecast. So you have all of that. In our case, what we did is we looked at the ET estimate of the past 3 days, multiplied that by the percent of the ground that was covered by canopy, and use that water use as our guidelines to irrigate with the medium discharge rate. So automatically we would get the lower discharge rate be under irrigated and the highest discharge rate to be over irrigated. So for that canopy cover, I mentioned we used an app. The app is called Canopeo. It's developed at Oklahoma State University. It's free to use. The way that it works is you simply hold your phone above the top of the canopy, at least 2 feet above the top of the canopy. You take a photo. The app takes that photo and gives you a percentage. It turns it into a black and white photo and gives you a percentage of canopy cover. It also gives you the option to adjust it a little bit if you feel like that it's not correctly capturing the green pixels. You can adjust it a little bit and get a value. In our experience, it's been working really nicely. We've never done any adjustments. We just take a photo. Right there, we get the percentage of ground cover. And the best thing is it's free. So let me share you some of the results from our 2025 season. This year, the summer season, we had bell and jalapeno peppers. This chart here shows you our cumulative total irrigation for the season. This only includes the part of the season when we started using this irrigation method. For a few days at the beginning, we were just irrigating a little bit at a higher rate and kind of similarly to ensure that the transplants survived the shock and they could keep going. And then as soon as we started using this management method, we started recording the data and showing it here. So you can see all 3 of them started at 0. And by the end of the season, the tape that had the smallest discharge rate, 0.25 gallon per minute per 100 feet of tape, had applied only 9 inches. The one in the medium range had applied 20 inches, and the largest discharge rate had applied 27 inches of water for our summer season. And you can see that that impacted canopy development. So we started like in early July, everything was about maybe 10 to 15%. The crop started growing with irrigation and all of that, GDD. And then, but you can see, especially in case of jalapeno and even with bell peppers, that there is a separation between the lines. The maximum numbers of canopy cover I'm showing on the screen, so 90% for bell pepper and then 76% for jalapeno, but there's some difference there. And then these are the yields. So for the weeks that we harvested, I'm showing the cumulative yields here, kind of like with irrigations. But the total values for bell pepper, we had 12.8 pounds for the smallest discharge rate of tape, 15.1 and 22.1 for the largest rate. For bell peppers, we had 6.3, 9.5, and 11.8. And if you plot the total yields versus irrigation, we'll get something like this. So these are the 3 points that show yield versus irrigation. By the way, we had at least 5 replicates for each of these treatments. So any dot you see on the screen is an average of 5 different replicates from those 3 high tunnels under different conditions. So it really represents the variability in soil and the high tunnel and everything else. So what this tells me is you don't see the lines, the trend lines that have been fitted here. You don't see them plateau at this high rate or before that. So as we apply more water, we keep getting larger yields for the 3 rates that we had. And what this tells us is that we were designing this method hoping that the middle discharge, the 0.56 gallon per minute, would provide enough water to replace the amount of water that was used, but it seemed like that was not the full irrigation because what we intended to be over irrigation gave us a larger yield. So that one was closer to full irrigation. Maybe actual full irrigation was a little bit larger. We don't know, but it's something that we're going to go and check. We think what's going on is the condition under the high tunnel ended up in increasing that water demand. It's a little bit difficult to tell because you don't get wind, or if the sides are up, then you get some wind, but generally speaking, you get a little bit reduced wind speed and you get a little bit reduced solar radiation because it has to go through the plastic. And those 2 things work in the direction of lowering the water need. But then you have higher humidity also in there. So we were thinking that if we use the Mesonet, Nebraska Mesonet data, which is outdoors, then this should be multiplied by the canopy cover. It should be giving us the full irrigation, but apparently it didn't. So we still have stuff to research on and look into and fine tune the method to be able to come up with the best irrigation approach. There are also some additional lessons that we learned, so I'm going to share a few of those with you and end with that. I don't know how easy it is to see or not, but there's right there in the tape, there's a huge leak. Water is shooting out. So what we learned is there is a big difference between thin-walled drip tape and thick-walled drip tape. We went with the thin wall because it's a 6 mil. Because 6 mil Toro was the only product where we could get 3 different rates while keeping every other characteristics of the tape the same. So wall thickness, emitter spacing, all of that, tape diameter, everything the same. So we went with the 6 mil, which turned out to be too thin. We would get a lot of holes in it and a lot of damage. From weeding, if you were using a hoe to weed it, if you touched the tape, it would create holes in it, cause holes in it. From rodents, we also had some damage, not too bad. We still needed to repair some of those damages, but it was not too bad. And then just rubbing against the soil, especially when we didn't have the straw mulch on top of the soil and then drip tape on top of that, when the drip tape was in more direct contact with the soil. Soil can get really dry in these high tunnels between the emitters because if water is not going there, then it gets really, really dry. The edges of the soil clots could be really sharp. And then when you turn irrigation on and off, there's a movement in the tape from the pressurizing and depressurizing, and that a small movement, if it happens a few times, you could get a hole or a cut right there. And the way we manage the irrigation is once we determined like for how many minutes we need to irrigate, then we did a couple of different irrigations during the day, not just one event per day, but multiple events. So you have 4 to 6, 7, 8 times of irrigating and stopping, sending these pulses. So there's a lot of movement of the tape that could eventually cause some damage. Okay, so we talked about discharge rates. I also looked into the impact of the wall thickness on the price. And I recently got these prices off of one of the websites that sells drip tapes. So these are all for a single roll of drip tape. Usually, if you buy multiple rolls, you can get a discount for large volume. But the length, I looked at the options where the length of that single roll, at least a few 100,000 feet. Some of the online stores also sell the rolls in small, like a few 100 feet length. So I looked at these are the conditions where I looked at it. And then I looked at just the tape diameter of 5/8 of an inch. There's also 7/8 of an inch diameter, but 5/8 of an inch is by far the most common. So I only looked at that. So here you can see 3 different products, brand name. Again, this is just for comparison purposes, not that any of them is endorsed or recommended, but just so that you could compare. The same emitter spacing, 8 inches. The emitter flow is in gallons per hour. They're about the same. Then you can see different wall thicknesses and prices. So 6 mil on the price per 1,000 feet of tape, 8 mil thickness, and then 15 mil thickness. I made the middle columns, which are all 8 mil wall thicknesses, in bold. You can see they're relatively similar prices, especially for the first 2 products. And then you can see compared to the 6 mil, they're only about $4 to $5 more expensive per 1,000 feet of tape. So for us, that was definitely not a problem. I think it was well worth paying a little bit more to go with the 8 mil. You can see with the 15 mil, then the difference is larger. It's about $30 per 1,000 feet. Still, that may not be much for some producers, depending on the size of their operation and how many thousands of feet of tape they need. So they can look into it and see if that $30 extra per 1,000 feet is worth not having to repair as many damage in the tape. Soil preparation was something that we found out that was important in our case, especially because, like I mentioned, there will be parts of the high tunnel, these productions under protection, that never get any water. If you use micro irrigation systems that don't wet the entire surface, then there are parts that are going to be there, no rain and then no irrigation. So they could be really, really dry, and they could get compacted from foot traffic. There could be salt buildup. Again, especially with micro systems, if you're not wetting the entire surface with the sprinklers, then you'll have salt buildup at the edges of the wetting front, and you would have that with even the best quality water, because the best quality waters still have some salts in it. And if they're always evaporating, the water is evaporating, leaving some salts behind, and you're not getting any rain to leach the salts, they could eventually build up. So the soil preparation helped with that. After each season, we would go use a tiller and a roller to cultivate the soil. Then we would apply straw mulch, and then we would irrigate the entire area with the sprinklers. It was important for our research purpose also because we had variable irrigation rates. So before we started a new season, we wanted to make sure that there's no impact of previous seasons, lack of irrigation on next season, because we always randomize our plots. So we would apply water with sprinklers, leach some of the salts, bring the water content up, make it uniform, start the next season. It would also, that a sprinkler irrigation would help with breaking some of the soil clods a little bit too. The tractor you see in the photo is BCS tractor. It's their model 853. So then we had a tiller attached to it, and then a roller behind the tiller. It was relatively easy to work with in this environment, and you see a graduate student using the tractor there. This is a photo of the sprinkler. It's just a simple portable sprinkler system that we used. Like I mentioned, we want to make sure that moisture was uniform. We wanted to leach the salts and further break those big clots. We do not recommend irrigating the bare soil. It could create surface sealing, especially if you just use something like this with a portable sprinkler that you can find at any retail store. In our case, we were connected to city water, so it's a little bit higher pressure. higher pressure typically results in smaller droplets, but if your pressure is not that high, you can get larger droplets. And if those droplets are hitting the soil surface directly, it could destroy the soil structure and cause surface sealing, which really reduces infiltration. So if possible, if you're planning to incorporate mulches in the operation, then our recommendation is to irrigate on top of the mulch. So that's all I have for today. Thank you very much for your attention.
Great, wonderful. Thank you so much. Really informative. I appreciate all the information there. So just can you talk just a little bit about, and if anybody has questions, feel free to come off mute or pop them in the chat there. How do you So if how do you share this information out with small farmers in Nebraska, or what's kind of the plan for kind of, getting this out there? This seems like really useful information, particularly as we think about, how much water do we need to deliver for these specialty crop systems that are undercover? Obviously, water conservation, a really important factor here. So just kind of your thoughts or your plans for how does this information get out through your work to the small specialty crop producers of Nebraska?
Yeah, great question. We're starting to do more of that now that we have a couple of seasons and some results to share and some lessons learned. We are working on kind of like an extension series with crop watch articles that we're going to put together explaining all aspects of irrigation hardware and software, management of the system. We've offered multiple training events in collaboration with Nebraska NRCS. These have been mostly designed for NRCS employees as they go through evaluation of requests from small scale producers. We've done that. We've held events at our site here on East Campus. We're incorporating more of this in our teaching and in making sure that the courses that we teach, we spend some time on small scale irrigation. And then also presenting at events and conferences and like this one today, and then there's a couple other conferences that are coming up in January next year and later that I'm going and presenting these results and trying to reach out to producers. The on-farm, if you will, the commercial side evaluation that we do has been also very rewarding because we work directly with producers, and as we go to their farm to do the audits, then we share some of the results that we have with them and to see what they have. I see great methods and very creative solutions that our producers are coming up with in terms of systems and management approaches. So I'm always learn a lot, and those are great discussions when I have it with producers.
Awesome. That's great. And you mentioned kind of seeing an increase in specialty crop producers in the state. We see this as well. There's just an ever-growing kind of interest in serving local markets and, kind of serving that local food space. We also kind of have been hearing more and more from row crop farmers, kind of your more commodity producers, larger scale, who are starting to think about, how can I diversify my operations? I'm wondering if you are hearing from row crop farmers about similar things, kind of a renewed interest in, diversifying their production systems, reaching different markets, or kind of, does any of this you feel, is it apply to those folks? Are there applications of these kind of more controlled environment systems that could fit into a commodity system, production system, or row crop system out there?
Yeah, another great question. One thing I like about a smaller scale is that it really fits in any setting. So you can have it included in your larger scale operations. You could have it in your urban farming settings,
Yeah.
and it doesn't matter if it's a small town or it's a large town. There's a lot of this going on in Omaha. NRCS has been providing support there in North Omaha, turning some of the vacant lots into very productive small scale operations, increasing food security and also the nutritious value of food as well. Yeah, I think it could be something that may work. Obviously, the conditions are very different, and each person needs to look into their own situation. But with high tunnels, it's relatively speaking a small investment when you think about larger scale farming and the costs that we're used to, the cost of a 7-span center pivot and a combine, all of that. When you think about this, folks going to start with a high tunnel, regular sized tunnel, relatively low investment, and just see what they can grow. And the irrigation components are typically not that expensive. It does require labor at times when there's harvest time, or if it's something that needs to be harvested a couple of times every week. So that labor requirement is something to keep in mind. If it's not available, that could be a bottleneck. But otherwise, I think these are could be great additions to larger scale operations.
Yeah, excellent. Great. Any other questions from the group? Okay.